Welcome back to Business Mathematics 2, MA 1203. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So for this occasion, we will learn about what is meant by matrix and its operation. Let's start. The first, we are going to review what is matrix and some of its operation. So we already are familiar with matrix. Generally, matrix is an ordered rectangular array of numbers, such as this. This is a matrix. You have two rows here. This is the first row. You have four entries, 1, 3, 2, 5. And you have the second row. You have four entries also, 2, -1, 3, and 8. And you have four columns here. The first column is 1, 2. The second column is 3, -1. The third column is 2, 3. And the fourth column is 5, 8. So the entries of the second row and the second column is the second row and the second column is -1. What about the entry on the first row and third column? The first row and third column is 2. Okay, yeah. Size of this matrix, we usually say this number of row times the number of column. So you have 2 times 4 matrix here. Okay. So what about equality of matrix? So how can you say that this matrix equals this matrix? Okay, these two matrices are equal if all of their entries is the same. If all of their entries component wise is the same. Yeah. So A should be equal A squared, B should be equal 1, 2 should be equal 2, and 3 should be equal 3. So find all possible A plus B that satisfy this. So if you have two matrices the same, so all the entries component wise it should be the same. So you have A should be equals to A squared. So you have A squared equals A. Don't forget you cannot here you have to factorize, bring it to the left hand side and factorize. You have A equals 0 and A equals 1. Don't forget you cannot cancel out this. If you cancel out this, you lose one of the solution, that is A equals 0. Okay, so you have A equals 0 and A equals 1, but B should be 1. So if A should be 0 or 1 and B should be 1, so the possible A plus B is 0 plus 1 or 1 plus 1. That is 1 or 2. Okay. This is the special matrix, identity matrix. So or the diagonal entry should be 1 and the other should be 0. This is identity matrix. Symmetric matrix, we usually say that the transpose is the same. Yeah. Okay. Yeah. Or we can look at this as reflecting it. 2 should be equals to 2 for reflecting it with respect to the diagonal. 1 and 1. Okay. Yeah. -3 should be equals -3. So this is the symmetric matrices. Upper triangular matrix, the entry is just on the upper triangular 1, but it can also be 0. But the lower it should be 0. This is the lower triangular matrix, lower triangular, and this is a lower triangular matrix also. Yeah. Okay, then we will continue to the matrix addition, subtraction, and multiplication. What about addition and subtraction? Oh, okay. For addition and subtraction, you have to add it and subtract it component-wise. So if you have this, you have the first column, first row, you should add with the first row, first column. And the second row, second column, you should add with the same component, second row and second column. So you have 1 plus 2 here. The first row, second column, you have 3 plus 2, 1. And the second row, first column, you should have -1 plus -1. And the second row and second column, you should have 2 plus 2. So you have this one. Okay. And you can try to evaluate this. Determine first whether the solution exists or no. Conclusion: two matrices can only be added or subtracted if they have the same size. Okay. And what about multiplication with scalar? So if you have this multiplication with scalar, you multiply it by per component. So you have 5 times 1, 5 times 3, 5 times minus 1. So you have this one. And you can evaluate this. So when a matrix is multiplied by a scalar, a constant, then all the entries are multiplied by that scalar. Okay, the next one, this is the multiplication of matrices. Let's look at this. Don't forget, when we are multiplicating matrix, when we are multiplicating two matrix, if I have this one, you multiply with maybe 3, 1, 0, 2 maybe. Okay, so if you want to multiply this, if you want to have the first row, first column, so you have to multiply the first row with the first column. Okay, so what does we have here? 1 times 3, component wise, 1 times 3 plus 2 times 0. Okay, what about if I want to have this one? What is this one? This is second row, first column. So you have to multiply second row with first column. So what you have here? 3 times 3 plus 4 times 0. Okay, and you can do the rest. So if I have this one, blue, black, I think. So if I have A, B, C, D, so what is the size of the multiplication of the matrix? Don't forget, yeah, you can have just this times this. So you can just have one row, one column. So you have AC plus BD. Okay, because it just contains one row and one column. Okay, what about this one? Uh, what about this one? You have one rows and two column. So the result will be have one row, one column, and one row, the first row, two column. So you have this one. Okay, we usually look at this like this. The size of this is 1 times 2. The size of this is 2 times 1. So the result, the matrix should be 1 times 1. What about this one? This is 1 times 2. You multiply with 2 times 2. So the result will be 1 times 2. What about this one? This is 2 times 2 with 2 times 2. So the result should be 2 times 2. Okay, yeah. This is you can look it fast like this. Okay, so this, if you have already this, you can multiply it. 2 times 4 plus 3 times 6. This is the first row, first column. The first row, second column is 2 times 5 plus 3 times 7. So you have this, and you can do the rest. It's the same. What about this? Okay, try to do this. If you want to do this, remember you must determine first whether this multiplication, whether the result of the multiplication exists or no. Okay, and the two matrices can be multiplied if the number of column of the first matrix is equal to the number of row. Okay, so how can you know that you can multiply two matrices? You have to have the same this. You have to have this. If you have this the same, then you can multiply. If this is not the same, you cannot multiply those two matrices. Okay. Okay. Later we will learn about the other three matrix operation, that is transpose, determinant, and inverse. Thank you.